Yes, hello, you have Sven BJ here, and we have going to go the next problem in thermodynamics, pure substances. We have this problem here. We have 10 kilos of R134 in a big tank, a 1.348 cube meter container. Also this R134, that's the kind of liquid that they use in refrigerators. It's a refrigerant item, liquid. So we will look at that. It's in a container, yes, with initial temperature of negative 40 degrees Celsius. The container is then heated until the pressure is 200 kilopascal. Determine the final temperature and the initial pressure. Yeah, so what we must do here. Yeah, well, first I would look at the table for the refrigerant R134 to see what that excuse me. Yeah, I will look at the table first to see if we can find something helpful information there. But we know it is initial temperature of negative 40 degrees. What is that means? Let's see here. Negative 40 degrees. Here we have negative 40 degrees. Then we can use this. We can. Let's just use this. Let's take this boat here, just for structure. So, so yes, we have this. When the temperature is negative 40 degrees, for it to boil, we need to have 51.25 kilopascal. But it is not quite sure this is saturated. This is a saturated stuff. It can be super heated or undercooled. We don't know that, but we do know that 10 kilo of this liquid fills a 1.348 cube meter rigid container. Rigid, it means it cannot be expanded because it's solid. So it means that it is filled up. It means that part of this, or everything for that case, must be vapor. Which means this cannot be an undercooled liquid, but it can be superheated. So let's look at the specific volume of this. That will help us. We know we have 10 kilos. Let's just write that things down here. The mass, total mass, 10 kilo. We have the specific volume, VF. The specific volume of the refrigerant in the fluid form is 0.000753 3 per kilo. And VG is 0.36064 3 per kilo. So, as you can see, it is it's not filled with liquid, that's for sure, because if you see on this one, the fluid, the specific volume, you can see that if this is filled up completely, that container, that's 1.348 cube meter, it will be like 2,000 kilos. And we don't have 2,000 kilos, we have 10 kilos. So it's not all liquid. It's not undercooled, definitely. But let's look at the let's just look at the gas. How much would a gas weight? I think it is about, let's just write it. Let's just write one of them off, just to show. So the mass will be then, excuse me, I have to think for a second before I do something. Yeah, it is there. 1.348 3 divide 0.36064 3 divided on chill. Okay, you see the cube meter disappears, and we have kilos. Yeah, and then you will see that if the entire container was filled with gas, and it will be like the saturated, it would be, write it on the calculator here, 1.348 divided on 0.36064. Answer is 3.74 kilos. So what you see here is that it would be only 3.74 kilos. It means that some of this must be liquid, and that means we do have saturated refrigerant, a saturated mixture, and that's why we know for sure the initial pressure is 51.25. I write it. The initial pressure is then 51.25 kPa. Because we know that because we can clearly see that since the mass of 1.348 of the fluid is steam, then the weight is less than 10 kilo. It means that some of it must be in liquid form. And that means it is a saturated mixture, which we will only have at 51.25 kilopascal. that red to indicate that this is the answer for the first question. Okay, the other determine the final temperature. What is the final temperature? The container is heated until the pressure is 200 kilopascal. What happens if the container is heated? Well, it's of course increased in temperature. It will be, it's the same rigid container, the volume is the same, but obviously it must be some more steam. Let's just try to look at the table, how that looks like. We go back here. How was it? What was that now? How was it? It's heated until the pressure is 200 kPa. Okay, I must like see the. Let's see the pressure table. Pressure table. There must be a pressure table here. Pressure table. Okay, 200 kilopascal. Okay. Yeah, okay, so we heat it up. Of course, if it is a rigid container, a solid container, it's locked. The container is locked. Then the pressure have to be increased as well. So the pressure will become 200 kPa, and then the heating stop. Of course, the heating have stopped. So is it possible that they saturated the mixture? No. Let's just look and learn. Let's see. We have the table saturated. Let's see. 200 kilopascal. Let's see how that looks like. There. Let's see. Okay, 200 kilopascal. If it is saturated, it is 10 degrees Celsius. Is that the answer? Negative 10 degrees Celsius. Oh, okay, how big was this one? 1.348 cube meters. And then max, the total mass is 10 kilo. If we have let's look at it. The specific volume of VG. Let's look at this. How much, if everything is gas or steam or vapor, how much will it weigh? How much will the weight be? So let's see. 0.09951 per kilo. Och det är ju det ska ju ha 1.348. Yeah. What is this? This is annoying. Klipp ut. Ja. Like that. Ah, there we go. Okay. And then we will see the answer. What is this? I will type this in the calculator. 1.348 divided by 9, 0.999099951. 13.4866 kilo. It will be. So that would be too heavy. Too heavy would it? So it means it's, how does that work? It's too heavy. It's too heavy. Will it be lighter if you turn it on to liquid? No, it will be more heavy. So how does that work? Well, it just means that that's not the specific volume. That's not the correct specific volume. And that means the refrigerant must be superheated, and we must go look at another table for the correct answer. So let's see at the kilopascal 200 in another table. Here, superheated refrigerant. We have 200 kilopascal. We will look at these places. Here, 0.2 megapascal. Megapascal. So we will now see. Where do we go now? Yeah, well, what we know is, as we know, the total amount, total mass is 10 kilo. The volume is the same, 1.348 square cube liter. And then let's just get the table to the, let's just copy a table here. We have to do everything. You have to get it all to see. Here. Let's copy it. Okay, we know here a specific volume is that line here nearby. That we know. So it means that yeah, because it's 10 kilo, it means that you can see that the specific volume must be 0.1348, and we have no fluid here, we have only the gas, and this is about gas. It's superheated, so it's gas or steam only, to call it like that. So we can see that number we are looking for, 0.1348, is between these two. It's between here. It means the temperature is between. The temperature must be between 60 and 70 degrees Celsius. So let's look. Let's see. We have this. There we have 60 and 70. Let's see. So to find that, there is like there is formula, the interpolation to find the in between there, because we will just make a linear so we will I will just write you the equation here so you can see how it does. So yeah, it's basically like this. There you have it. Like this. So that means So that it means it will be like this. So it's there. I must have some there. That's the temperature we are going to find. And then 60. The y0, it will be that one, 60. And then we have to make it properly, you have to put this. And then x, that will be the x you see here, that will be the other number. That one we know that one. That's 0.1348, was it? Was that correct? I think so. And then minus the negative, minus, if it's minus in English. And then we have we have 0.13641. So, and then it's the same as E. Let's see what is E1. That will be the temperature 70, negative 60. Because you know it's linear. The relationship it will be the same. That's why this works. Okay, and then for zero. Oh yeah, I see. I wrote something wrong, by the way. Because I just didn't look correctly in place. So that I will fix. So it's like this. And then I must change this number. It's not going to be. It's 132 222 06 06. So. Oh wait, now what did I miss here? Yeah. Minus 1.3206. Nej. 0.13206. Now what did I do now? I have done 13641 13206. There we have it. So you see, there is an equation. We will just solve to find the t. I hope you guys know how to do a simple equation like this. I can show you. Well, you know the basic rules of this is to, you have to take this here, these numbers. You want to get the t alone on one side, to find the number, and then you must take this, and you will move these numbers over here, and then you will just use the calculator for all this, and then you will just take the negative 60, change this front sign to plus, when you move it over here. And then you have answer for t. I will write if you didn't understand. If you're new beginner, you did not understand that, I will do that for you. So I have to, it's so just so slow to write on the board like this. So I just take the calculator on these simple numbers as they stay. For example, I take 70 minus 60, and you know what you get, and then you take and divide on that number there under 0.13641. Yeah, 0.13206. Sant? And you get and then you multiply. Okay. You see, and then you will multiply all of this. That say with that one. I will write that on the calculator. So I'm tired to write everything. And then let's go see 0.1348 minus 0.13206. And you get 6.2988. So now you have the number 6.2988. And then, yeah, you have that number here. And you just move this 60 over there. So you get plus 60. And then the answer will be 60 plus 6.2985. Yeah, it's too many decimals. Okay, but it will be 66.3 degrees Celsius. That will be the answer. I remember on this one, there was an answer standing there up. Let's go up and see. Let's go up and see. Yes, look here, answer 66.3 degrees. And there you have 66.3 degrees. Amazing, amazing. So that's how you do problems like this. I'm going to do more. I don't know what my next will be, but I will choose one and just follow for more engineering problems in the future.